So this one says, write an algebraic expression to represent each of the following calculations. And it says use x to represent the number. So we're going to increase our variable x by 5 and then by 35%. So what I can say is that I'm going to have my variable x. So the first thing I'm going to do is increase it by 5%, which just means add 5, right? And I'm going to increase that number by 35%. So 35% as a multiplier is 1.35, right? So I have to put that whole thing in parentheses because I'm not just increasing the number by 35%. I'm increasing the number that was already increased by 5 by 35%. Okay? So that's different from part B, right? So part B says we're going to increase a number by 35%. So I have x, and I'm increasing that by 35%, so a multiplier of 1.35. And then I'm going to increase that by 5. So now I'm just going to add 5 to that. Right? So we can see that the order that we introduce something matters, right? Whereas if you increase something by 5 first and then increase that by 35%, it's different than increasing the first number by 35% and then adding 5 as our second step. And I think that part C is a repeat of part A, and part D is as well. So I just accidentally copied those twice. So I'm going to omit C and D. Okay. So E says quadruple a number. So I'm going to have my variable x, I'm quadrupling it. So what does quadrupling something mean? What am I multiplying by?
4.
4, yep. So I'm going to have 4 multiplied by x. I'm going to decrease that by 10%, or by 10 rather. So I'm just going to subtract 10. And then I'm taking 80% of that, right? So how can I do 80% of this right here? So what multiplier is 80% of something? Well, that's just 0.8. Yep.
Or 0.8.
0.80 or 0.8. Yep. So I'm going to multiply this whole thing by 0.8. Yep. So that's our expression for this one. F says we're going to take a quarter of a number. So that's what, 1/4, right?
Mm-hmm.
So 1/4 of x. Okay, so that's the first step. We're going to add 15. I'm going to add 15. We're going to increase this by 10%. So my multiplier here would be 1.1. So multiply the whole thing by 1.1. And then I'm going to increase that by 25%. Right? So I'm going to put another set of parentheses, and I'm going to increase all of that by 1.25.
Oh.
Right? So if I go kind of backwards just to explain this, so we take the 1/4 of a number, we add 15 to it, which is our second step.
Well, wouldn't that though? Oh, you're doing this stuff in the parentheses first, so you'll be doing 1/4 times 15.
Right. So now that we're back to
1.1. Okay.
Yep, absolutely. So now that we're back to expression, so we don't have an equal sign. Now we're doing PEMDAS again, right? But we're actually going down the pyramid again. So we're starting with the parentheses and then so on. Yep. Okay. Yeah. Okay. Any questions on this page? Okay. Okay. So this is probably the longest problem that we'll ever have in this course. So we're just going to kind of keep adding to it. Okay. So this one says, a local bar and grill is having a quarter wing night during which chicken wings cost $1/4 each. So it says, as you leave your home to join your friends there, all you grab is a $20 bill along with your ID, phone, and keys. So it says, determine how many wings you can purchase if you also want to buy a pitcher of your favorite beverage for $5. So how can I solve this numerically? So I start with $20, right? I need to subtract the $5 off for the pitcher. So we subtract 5. So we turn out with what, $15 left?
Mm-hmm.
So we have $15. And I want to know how many wings can I buy with $15? So what do I have to do to that 15 to find out how many wings I can buy?
Divided by 25.
Um,
Oh,
well, the wings aren't
well,
$25 each, right?
oh, no, yeah, okay.
Yep. But you're on the right track. So I divide by 0.25,
Yeah,
right? Or I need to divide by 0.25. Yep. So divide by 0.25. And how many wings can I get? Well, I think that's just 60, right? Yep. So I could buy 60 wings. And that makes sense, right? Because you can get 4 of them for $1, and 4 times 15 is 60. Yep.
huh,
So if I want to write this as an algebraic equation, so my number of wings that I can buy is equal to, so I'm going to leave a little space because I have to write this in. So whatever I can buy on the left side is equal to the $20 that I brought with me, right? So instead of subtracting 5, we're going to add 5 on both sides, right? And I know that the wings cost 25 cents each. So I'm going to multiply this by 0.25, right? So we're just kind of doing the backwards of what we did in the first part. So I know at 25 cents a wing, plus the $5 for the pitcher is going to add up to the $20 that I have in my pocket, right? So if I wanted to solve for W, what I would do is subtract 5 on both sides, which is the first step that we did. And then I would divide by 0.25, which is the second step. So I know that W here, so the number of wings that I can get is going to be equal to 60, right? So we're just doing the same steps that we did in part A, okay? But what if we make this more complicated, right? And you're going to hear me say that a lot because that's all we're going to do is we're going to make this same problem more complicated. So we're going to add a step each time. So the next one says, suppose we have the same situation again, but this time we buy blue cheese dressing to use on the wings, right? So I'm going to start with the same equation that I had up here. So I'm going to skip solving numerically now because I think that gets really repetitive really fast. So I'm going to start with the same equation that I have. So I have 0.25 wings plus the $5 for the pitcher. I'm going to leave a little space here. That equals to the $20 that we are bringing with us, right? So what do I need to add on the left side still to make this true? Because I have a new condition, right? We're buying blue cheese. So what I need to do is I need to add another $1.50 on the left side, right? So now I have at 25 cents a wing, plus the $5 for the pitcher of a beverage, plus the $1.50 for the blue cheese dressing is going to equal to the $20, right? So now what I can do is I can combine these two. So we get 0.25 W plus, what, $6.50 equals $20. Okay? So I'm just combining my like terms. And now what I can do is I can subtract $6.50 on both sides. So basically what I'm saying is I'm taking $6.50 out of both sides to see how much money I have left over to buy wings with, right? So if I subtract $6.50 on both sides, we get 0.25 W is equal to, and 20 minus 6.5 is 1350, right? And then finally, we can just solve for W by just dividing by 0.25 on both sides. So we get W divided by 0.25 on both sides, and we get 54. So I can buy 54 wings now with the money I have left over after I bought the blue cheese dressing and the beverage. Okay? And that makes sense. So I can buy less wings because I spent more money on things other than wings, right? In this case, the blue cheese dressing. Okay. The next part of this equation. So it says, suppose you want to buy wings, a pitcher for $5, the dressing for $1.50, and add a 20% tip. So it says a friend says, just figure a $4 tip since $4 is 20% of $20. So and then figure out how many wings you can get. So it says determine the number of wings you can buy and the percent tip you'd be leaving if you followed his advice. So we're going to start with the exact same equation up here. And I'll go down a step. So I'm just going to go into this step here where we're at 650. So I have 0.25 W plus the 650. So I just already combined the blue cheese dressing and the beverage. And then plus, now we have a $4 tip. So this is plus $4. And that's going to equal $20. Right? So we're just adding another step to it. So I'm going to do the same thing that I've done before. I'm going to start solving for W. So what I can do is I can subtract, 1050 on both sides? And I'm subtracting 1050 because I've just combined these in my head, the 650 plus the $4. So we get 0.25 W on the left, and we get 950 on the right. Right? So we get to this step, and then we've done this before. We just divide 0.25 on both sides. So W equals, and then 950 divided by 0.25, we get 38 wings. So we can buy 38 wings if we do it with this method. Okay. All right. Any questions on this stuff so far? On this first page? All right. We will keep moving along then. So it says, notice that your friend's method did not result in a 20% tip. So does anybody know why this did not result in a 20% tip? The last page. So why did the $4 not result in a 20% tip? Well, 20%, it's a little bit different. When you're tipping someone, you're paying them for what you bought, right? So we haven't bought anything yet if we just say that we have a $4 tip, right? We're just giving them $4. We're not saying that we're doing a percentage of what we bought, right? So actually, we probably over-tipped them, right? If we only spent $16, we actually gave them more money than 20% because we only bought $16 worth of stuff.
So you get 80 cents more.
Yeah, exactly. So if we wanted to give them an exact 20% tip, we can do that, right? So I'm going to go, I'm going to add a problem to this. So it says we're still doing the $5 pitcher and the dressing for $1.50. So I'm going to rewrite that equation that we had on the last page. So we had 0.25 W plus the 650. That's going to equal the $20, right? But a 20% tip, we can look at that as a 20% increase in the price, right? So I'm going to multiply the left side. I'm going to put it all in parentheses by 1.2. So that 1.2 is just that 20% increase in price, which is the 20% tip, right? So a 20% tip is just 1.2 as a multiplier, right? We're increasing by 20%, right? So how can I solve for this? So we could do it a few different ways, right? We could either distribute the 1.2 to both of these, or we could do like what I did on the last section where we just divided by 1.2 on both sides. So I'm going to divide everything by 1.2. So the left side, the 1.2's cancel. Sorry, that should be 0.25 for W. 0.25 for W. Okay, so if I divide by 1.2 on both sides, on the left side I get 0.25 W plus 650. And that's equal to 20 divided by 1.2, which is $16.66. Right? Okay. Now what can I do to solve for W? So what can I do to solve for W here? Well, we can do just like we've done before, right? Where we're going to subtract 650 on both sides. So we get 0.25 W is equal to, and we get what? $10.16. Yep. Okay, and then we just divide by 0.25 on both sides. So we get W equals, so 10.16 divided by 0.25, we get 40.64 wings. So I know that places don't sell partial wings, right? They don't sell 0.64 of a wing. So I need to round this to the nearest whole wing, right? Am I going to round up to 41 or down to 40?
Down,
Yeah, so why am I going to round down?
because you won't have enough money.
Yeah, if we rounded up to 41, we wouldn't have enough money, right? So we
Right.
have to round this down to 40 wings. Yep, that's exactly right. So you can buy 40 wings with this method. Okay, so we're going to add one more step to this now. So I'm going to take my last equation that I had up here. So I have 1.2, and then in parentheses 0.25 W plus 650 equals $20. So this time we're incorporating a sales tax, right? So that's a 7% increase in price. So my multiplier for that would be 1.07. So similar to what I did with the 20% tip, I just need to multiply the left side by 1.07. So that's just my increase from my tax. That's just the increase of price from the tax. Okay. And then we can do similar to what we did before, right? So we can divide by 1.07, then divide by 1.2, subtract the 650, and divide by 0.25, right? So we're just going to do the same thing we did on this one, but we just have one extra step at the beginning. So I'm going to divide both sides by 1.07. So I have 20 divided by 1.07. So I get this part again, and I'm not going to rewrite it again. I'm just going to kind of go down. So I have 18.69 for this, right? We have to divide that by 1.2 next. So divide that by 1.2. We get that's equal to 15.58. So if we divide by 1.2, then we need to subtract the 650. Subtract 650. So we get $9.08. Yep. Okay. Or I guess it's it's 8 cents. Okay. And then after that, now we just divide by 0.25. So divide that by 0.25. And we get 36.3. Okay. So what that's saying is that I can buy 36 wings with the money that I have left over after all this, right? So I can buy exactly 36 wings. So all I'm doing is just working backwards again. So I just divide by this first, divide by that second, subtract third, and then divide again as my last step. Okay. Okay. Any questions on this one or any of these problems so far? Okay. All right, so the last one says, if the price per wing changes to 40 cents and the price of a pitcher changes to $5.50, how many wings can you afford for $20? So it says, assume you're still paying the tax and leaving the 20% tip. And then it says, which method do you prefer? So personally, I like the algebraic equation. So I'm going to take my algebraic equation from up here. I'm going to rewrite it down here, but I need to change a few things, right? So the first question I have is, did my tax change, the 1.07? Do I have a different tax percentage?
No.
No, it's still still 7%, right? So my multiplier is still 1.07. Did I change my tip percentage?
No.
No. So I'm still going to have 1.2. Did I change the price of my wings?
Yes.
Right, which is 0.4 now. So instead of 0.25 W, we're going to have 0.4 W. Right? did I change the price of this 650 at all?
Yes.
Yes. How did I change it?
Yes. To 550.
Right. So the price of my pitcher increased by 50 cents, right? Because it was originally $5.
Oh, yeah, that's right.
Yeah, so it's that 50% increase. So instead of adding 6.50, I'm going to just add 7, right? Because we have a 50% or 50-cent increase. So I'm just going to add 7 there instead, right? And then that's all I changed, right? So I've dealt with all 4 of my numbers, and I still have the $20 in my pocket, right? So all this is going to be equal to 20. Right? So what I can do is similar to what I did up here. So I'm going to divide by 1.07, divide by 1.2. So that hasn't changed yet, right? So when I do those first 2 steps, I'm still going to end up with 15.58. So if I do the first 2 steps. So I have 0.4W plus 7 is equal to 15.58. Because we're doing the exact same 2 steps as we did on the previous one. But now instead of subtracting 650 like we did up here, we're going to subtract 7. So I'm going to say 0.4W equals, so I'm subtracting 7 on both sides. And we should get what, 858? Yeah, so we get 858. Okay, and then finally, instead of dividing by 0.25, we divide by 0.4. So divide everything by 0.4. We get just W on the left. And on the right, we get 21.45, just meaning that you can buy 21 wings, right? Because we have to round down to make sure that we can afford all the wings that we buy. Okay. Okay. Any questions on this page? Okay. All right, I think we have one more page to do then. So we're going to solve for some equations. So they're already going to be made for us. So it's going to be very similar to the last section that we did, but now we have more steps involved, right? So let's start solving for this first one. So this first one, we have 0.25 multiplied by x minus 2 plus 0.6 equals 1.29, right? So what's the first step that we could do to start solving this equation?
I would add the 0.52 plus 0.6.
So you would add these two together?
Yeah, but I don't know if that's right.
So we're multiplying this 0.52 to everything in the parentheses, right?
Okay.
Right?
Yeah, I'm wrong.
Yeah, so let's try that first. Let's multiply 0.25 to both of these in the parentheses. So we kind of start simplifying this side. So we get 0.52x, and then we get 0.52 multiplied by negative 2, which is negative 1.04. Yeah, negative 1.04. Right, and then we're adding 0.6, and that equals 1.29. Right. So now this starts looking really similar to what we've done before, right? We have x's, we have some constants, and we have another constant, right? So we can combine these two next on the left side. So I have 0.52x minus, I think it's going to be minus 0.44. Yeah. So we have a bigger negative number, so we're going to have minus 0.44. And that's equal to 1.29. Yep. Okay. Now, what can we do? So what's our next step here? So what's my next step in this equation? Well, I need to start isolating x, right? I need to get x by itself. So what's something I could do to start getting this x by itself? What do we think? Anybody have any ideas? Well, one thing I can do is I could just add 0.44 on both sides, right? So if I add 0.44 on both sides, that'll get rid of the constants on my left side, right? So I have 0.52x equals, and 1.29 plus 0.44, we get 1.73, right? And then finally, my last step is just dividing by 0.52 on both sides. So I get x by itself on this side, 1.73 divided by 0.52, we get 3.33. So I'm going to round it off to the second decimal place there. Okay. So 3.33. Okay. Okay, let's move on to the next one then. So the next one, I have a bunch of things going on, right? So I think what I want to do is I'm going to kind of follow a similar step to what I did on the first one, and I'm going to distribute this 1/3 to the parentheses. So I have 2/5 x plus, or minus, sorry, 1/3 x minus 1/3 equals 2/9x minus 5. All right, so I'm just distributing that negative 1/3. Okay. And the next thing I want to do is I want to start combining all the x's together and combining all the constants together, right? So what I'm going to do here is I'm going to get all my x's to the left side and all my constants, or all my regular numbers, to the right side. So what I'm going to do is I'm going to add 1/3 on both sides, and then I'm going to subtract 2/9x on both sides, right? So on the left side, I get 2/5 x minus 1/3 x minus 2/9x equals -5 plus 1/3. Right, so it's kind of a little messy right now, but I have all my x's on the left, and I have all my regular numbers, or my constants, on the right. So
can you repeat that third line again? I see where you did the first. Oh, could you just start with when you on the second line?
Yeah, so we're okay with this, right? Where I just distributed the 1/3?
Right, I understand.
Okay. Yep. So I distributed the 1/3, so we get down to this line, right? So what I'm doing is I'm adding 1/3 on both sides to get rid of all my regular numbers on the left, right? The ones without the variables. And then I'm subtracting 2/9 x on both sides to get all my x's on the left side. So basically what I'm doing is I'm getting everything with an x on it on the left side and everything without an x on the right side. And I'm doing that by adding 1/3 on both sides and subtracting 2/9 x on both sides. Okay? Does that make sense?
Yeah, kind of.
Okay. Yeah, so basically what I'm doing is just I'm getting everything with an x on the left side, everything without an x on the right side. Yep. Okay, so now we need to combine like terms a little bit, right? So this left side here, we're dealing with a bunch of fractions with different numbers, right? We have 1/5, 1/3, 1/9, and on the right side we have a constant and 1/3, right? So this kind of goes back to adding fractions, right? So how can I add, let's see, 2/5 together and 1/3 together?
Have the denominator be equal like a 15.
Yeah, so how can I make 2/5 x into something over 15?
Multiply it.
By
3.
Yep, multiply it by 3/3, right? Yeah, so if I multiply that by 3/3, we get what, 6 on the top and 15 on the bottom? So this first part?
Yeah.
And that is x, right? And then I multiply the negative 1/3 x by 5/5. So we get minus 5/15 x, right? And then I can rewrite the rest, right? So I have negative 2/9 x. And on the right side, what's negative 5 plus 1/3? Well, we're still going to have negative, right? If we add a third, it should be what, -4 2/3?
Mhm.
Yep. Okay. So I can combine my like terms now, right, with the x's. So we get a positive 1/5 x. So I have a 1/5x, or 1/15th rather. Sorry. So 1/15th x minus 2/9x equals a -4 2/3. And now I have these ones that I have to combine again, right? So how can I combine these like terms?
You can
Well,
always multiply 9 by 15 and get a common denominator.
yep. So we can do the exact same thing that we did before, right? So multiply this side by, or this one by 15/15. Multiply this one by 9/9. Yep. So let me check. 9 times 15 is 135. So on the left one, we get what, 9/135 x. And on the right side, or the right one, we get minus 2 times 15 is 30 over 135 x. And that's still equal to a negative, and I'm going to change this into an improper fraction. So I know that 4 times 3 is 12, and then I need to add the 2. So this is the same thing as a -14/3. So I'm just changing that into an improper fraction. And now I can combine these two on the left side, right? So how can I combine these two on the left side? Well, that's just like adding fractions, right? So we just add the top and keep the same denominator. So 9 minus 30 is a -21 over 135x. That's equal to a -14/3. Right? And then to get x by itself, we can either divide by this fraction or just multiply by its reciprocal, which is just flipping it and multiplying it. So I'm going to multiply both sides by 135/21, and I want to make sure it's negative. So multiply the other side by 135/21, make sure that's a negative. So on the left side, I know that they'll cancel. I'll just end up with an x. And on the right side, we're just multiplying two fractions. So I get 1,890 over 3 times 21, which is 63. Okay. And I kind of know, well, I don't really know, I guess, but if I just divide these two in my calculator, I notice that I get 30. So if I divide the 1,000 number by 63, we're going to get 30. So this is the same thing as just saying x is equal to 30. Okay. Okay, so that was a really long process, right? But maybe there was something I could have done to make this a little easier on myself. So when I look up here, I know that 3 is a factor of 9, right? So 3 times 3 is 9. And I know that 5 is not a factor of 9. Okay? So maybe what I could have done at the start is maybe I could have multiplied both sides by 45. And the reason I can multiply them by 45, or the reason I would do that, is because it would cancel all the fractions in the problem, right? So it'd be a lot easier to deal with whole numbers, kind of like we did on the last page. So maybe that was an option at the start to make this problem maybe a little bit easier than the way that we did it. But either way, we got the correct answer. We get x equals 30. If you plug in 30 for x, we're going to get a true statement. Okay. Any questions on that one? I know that was a long one. Okay. So let's do this. So let's try that second method that I just talked about on the next one to make it hopefully a little bit easier. So what can I multiply the left and the right side by to get no fractions? Well, We could just do 6 times 4, which are my two fractions. I get, what, 24? So let's multiply the left and the right side by 24. And the reason I'm doing that is just to get rid of all my fractions. So I'm going to put the whole thing in parentheses and multiply it by 24. And just to cancel those fractions, right? So 24 times 6 is 4, right? So we get 4 multiplied by x minus 1. So 24 divided by 6 is 4. And then 24 times 3x is 72. Right? So that takes care of my left side. My right side, 1/4 x multiplied by 24 is 8. So we get, or no, it's 6, right? Sorry.
6.
Yeah, it's 6. So we get 6x minus 24, because we have to distribute this to both of them. Okay. And then now we can start solving for this, right? So this is going to be a lot easier than dealing with all the fractions and stuff that we had. Okay. So I'm going to distribute the 4 to both of these. So we get 4 x minus 4 plus 72x equals 6x minus 24. So I'm just distributing it and leaving everything else the same. Okay. And now what I can do is I can combine my like terms, right? So 4x plus 72x, we get 76x minus 4 equals 6x minus 24. Right? And then now I can get all my x's to the left, all my constants to the right. So I'm going to add 4 on both sides. And I'm going to subtract 6x on both sides. Yep. So I get 70x on the left. And I'm kind of running out of room, so I'm going to do it over here. So I get 70x on the left, and on the right we get negative 20. And then finally we can just solve for x by just dividing by 70 on both sides. Divided by 70, we just get x on the left, and on the right we get negative 20 over 70, which is the same thing as negative 2 over 7. Yep. Okay.
Where did you get the, okay, I followed along until you got the 20. Where did you get the 20?
So negative 24 plus 4 is 20, right?
Okay.
Yep. Yeah, so I moved all the constants to the right, moved all the x's to the left. Yep. And then you're okay with the last step, right? Where I just kind of took 10 out of the top and the bottom. So 20 divided by 70 is the same thing as negative 2 over 7.
Yeah.
Okay, cool. Okay. So now we move on to the last problem then. And the last problem, we're dealing with a lot of decimals and everything again, right? So we could get really messy dealing with decimals and stuff, but maybe I don't want to do that. So what I can do here is that I see my longest decimal is this very first one, right? It has the most spots, which is 3. So what I can do to get rid of that is just move this decimal place 1, 2, 3 spots. And I can do that by multiplying it by 1,000, right? I can multiply this by 1,000 to get that number. So what I'm going to do is I'm going to multiply both sides by 1,000 to make sure that I don't have to worry about any decimals in this problem. So I'm going to multiply both sides by 1,000. So I get 1,359, and it's still multiplied by x plus 2, minus 0.25 multiplied by 1,000 is 250, still x minus 2. And then 2.5 multiplied by 1,000 is 2,500. So all I'm doing is just multiplying both sides by 1,000, so I don't have to deal with decimals anymore. Okay, and then now I can start solving, right? So I can distribute 1,359 and distribute 250 to both of these. So I get 1,359x plus 2 times 1,359 which is 2,718, minus 250x plus 500 equals 2,500. So I'm just distributing these two numbers here first. Okay. And then now what I can do is I can combine my like terms on the left side. Oops, there should be an x there, sorry. So I'm going to combine my x terms, and I'm going to combine my constants. Okay. So 1,359x minus 250x is 1,109x, and then 2,718 plus 500 should be, what, 3,218? So, yep. And then that equals 2,500. Right. So what can be my next step in my equation here? How can I start solving for x even more now? So I have two options, right? I can either divide by 1,109 on both sides, or I can subtract 3,218. Right? If I divide by this 1,000 number first, I have to divide everything by it. So I'm going to have to divide this by this as well. And I don't necessarily want to do that because I might get fractions again, right? So I'm going to subtract first. So subtract 3,218 on both sides. So on the left side, I end up with 1,109x, and that's equal to, so 2,500 minus 3,218. We get negative 718. Okay. And then now I can just divide both sides by 1,109. So I get x equals a negative 718 divided by 1,109. Right? So that could just be a fraction.